Hey NASA fans, my name is Alicia Bararoni Cortez, and today we are going to talk about some of the amazing research opportunities NASA has for students. You don't have to be a PhD to be part of some of the incredible research the agency supports. Whether you're in middle school, college, or a lifelong learner, NASA has a project for you. First, we're going to meet with some experts with NASA's Citizen Science Group. Mark Kushner is the Citizen Science Officer for NASA's Science Mission Directorate, and Dr. Carl Lewis is with the Fairchild Tropical Botanic Garden in Coral Gables, Florida, which leads the Growing Beyond Earth project. Hi Mark, hi Carl, excited to talk with you today. Our first question is for Mark. Can you tell us what is NASA Citizen Science? Who can participate and what kinds of problems are you trying to solve?
Sure, Alicia. So NASA scientists are asking for help from volunteers from everywhere, from all around the world. Anybody can participate to help solve NASA science problems. So folks contribute by looking at NASA data and commenting on it, marking it up, helping us analyze it. They often take their own data with their own backyard telescopes, other equipment, cell phones, can take data with cell phones. Um, there are a million different ways that people can contribute. Carl's going to tell you about a really cool project where they're growing plants. Um, the list goes on and on, really. Just every different aspect of NASA science has projects that invite you to take part.
All right. Well, so Carl, tell us about your project. Mark kind of teed you up there.
Yeah, our project is called Growing Beyond Earth, and we're at Fairchild Tropical Botanic Garden in Miami, Florida. But our project spans over 400 middle and high schools across the country, where we have students doing experiments with plants in order to support work that's being done on the International Space Station right now, and to support future expeditions into deeper space, where astronauts will need a source of food, edible plants, when they travel in space.
So what have been some of the outcomes of that project? So you've got students participating all across different places. Tell us some more about that.
Yeah, so we give the students the equipment like you can see behind me, and it's a plant habitat that's the same size and shape and lighting as what they have on the International Space Station, as the veggie plant habitat on the space station. So we have students testing a lot of different edible varieties of plants. You know, there's more than 10,000 different varieties of edible plants on Earth, any number of which might be useful for producing food in space. And so this is a perfect citizen science problem where we have thousands of students at over 400 schools testing these plants to see how they perform. And the ones that perform most consistently across all the different growing conditions in the different schools, the consistent ones are the ones that are most interesting for NASA for further study on the International Space Station.
So what actual data are the students collecting? Like what are they looking for in the plant growth?
Yeah, so they're really looking for how much food can be produced. So they're really measuring the plants as they grow. They look at the germination rate, they look at how quickly they're growing, and how much edible biomass they get out at the end. They weigh that, and we just get all of this mountain of data coming from all of the schools. So we can compare one variety of plants against another, and also compare different strategies for growing them and different strategies for harvesting.
So has anything surprising come out of that research?
Yeah, in terms of harvesting strategies, it's really interesting. You know, you think about when you're growing a head of lettuce, do you want to grow it up to its full size and harvest it once and eat it? Or do you want to pick a few leaves every few days? And so students were able to test those different strategies, and they found that just by harvesting multiple times while the lettuce is growing, they get a greater yield overall. So once they've had that result, that was tested successfully on the International Space Station.
Very cool. So, Mark, anything that you wanted to throw in on other projects you're aware of or contributions of this one?
Sure. Well, we're super proud that more than 500 of our volunteers have become co-authors on published scientific papers through their work on NASA citizen science. And many more have appeared at scientific conferences. I know that students from the Growing Beyond Earth project have helped present and have appeared at scientific conferences presenting their work. And we're just super proud of those students and all of the many volunteers and amateurs who are part of the NASA team.
So what I'm hearing is they're not only getting that research experience, but they're able to help go out and kind of act as actual scientists and sharing that research in the scientific community.
We think of them as our scientific colleagues, yes.
That's amazing. So thinking about those students that might be considering getting involved in something like this, I'm curious of what advice you might have for students. Carl, let's start with you.
Yeah, well, what we find is that we throw a lot of different problems, a lot of different research questions at the students, and sometimes the plants don't grow as expected or don't grow at all. And we think it's important for students to remember they have to share all the data back with us, because those failures, or what seems like a failure, is actually the most important result. We want to know all the things that can go wrong before these plants are sent into space, up to the space station. And so just to encourage students that we want all of the information, notes, if they notice anything unusual, just tell us about it. We can add that to this huge set of data that we're collecting.
And that's a really important point, Carl, because that's part of what makes participation in one of these citizen science projects so exciting is that it's real, right? It's not a manufactured problem that you're guaranteed if you turn the crank, it'll give you the right answer. It's the roller coaster ride of real science. And sometimes the roller coaster goes up and sometimes it goes down, but it's always a thrill.
Well, thank you both so much for sharing about the projects and the research. We hope that this gets a few more interested students maybe coming your way. So we really appreciate your time today. Thank you.
Thank you so much.
Thanks again.
For those interested in learning more about NASA citizen science opportunities, you can visit science.nasa.gov/citizen-science. Next, let's talk with a group of students from the University of Kentucky about their research involving heat shields, which are used to protect spacecraft during re-entry to Earth. Asa O'Neill, Bruno Taki, and Emma Nyheisel are part of a larger team working on the Kentucky Re-Entry Probe Experiment, or CRAPE project, sponsored by the NASA established program to stimulate competitive research, also known as EPSCoR. Hey guys, thanks for joining us today. We're going to start with Bruno. I would love for you to tell us about your project, what is its purpose, and what's involved in doing this research.
All right, so CRUPS, or the Kentucky Reentry Universal Payload System, is a series of capsules that were developed here at the University of Kentucky. So the idea is that with all the space exploration that's going on, there's a huge need for easier ways to test, to do experiments in this environment, and also to collect data to help researchers validate their models. So that's what CRUPS is trying to do. We're trying to develop an easier way of testing new heat shield materials and other advancements in real flight environments, and also to collect data so we better understand what's going on at hypersonic environments.
Okay, so Asa, tell us a little bit like why is that important? What's the real world application of that research when we're talking about spaceflight?
Yeah, so one of the highest risk portions of any mission to a planetary surface is actually the entry, descent, and landing portion of that. And so during that re-entry environment, there's really extreme temperatures, which is why we need those heat shields. And now NASA's looking to, they're doing a lot of missions to planetary bodies, such as becoming a Dragonfly mission and others, where they're going to actually need to re-enter atmospheres other than Earth's. But also for re-entry to Earth, it's really important that we understand the behavior of our heat shield materials, and that we, as Bruno said, gather data so that we can develop better models and understand that environment before we even launch.
So Emma, tell us, how did you get involved in this research project?
I got involved in this research project because our sponsor, Dr. Martin, reached out to me and encouraged me to take part in the project and to really get involved in research, and specifically in aerospace. So he thought it would challenge me and give me something, a new perspective on engineering.
And what was your reaction when he suggested that? Was this an area you were already interested in, or what was that like?
Yeah, so I was already pretty interested in exploring aerospace, and I was pretty excited to be invited to be a part of this project because it is such a big project to be a part of here at UK as such. And the team is so great. So I was really excited to be a part of it. I was excited that he reached out, and it was a great opportunity to get to know a lot of great people here at UK too.
And I'm assuming kind of upping your skills and giving you a lot of new knowledge and
Yeah,
experience.
for sure.
Awesome.
And yeah, definitely have learned a lot and gained a lot of new valuable experiences, especially with the project as a whole, the reentry and dealing with all of the different complex parts, has really taught me a lot of new things that I feel like I can apply going forward.
So that's great that you kind of queued up my next question, which was going to be to tell me like your favorite part of working on this project or what your biggest takeaway has been. So you want to continue on that thread, Emma, and kind of maybe go a little specific on something you might have learned or brought away from this project?
Yeah, I specifically have learned a lot about like the reentry process and about like how heat shields work with this project. It was something that I hadn't really like explored before, so I definitely have a deeper knowledge base about that now. And then I would say my favorite like part of the project has just been like working with the team. I feel like everyone is so supportive, and it's such a big project that everyone's willing to pitch in and like try to make this as great as it can be.
So I'm seeing Asa and Bruno do a lot of nodding with everything that you've said so far. So I'm going to pivot over to Asa and see what's your kind of takeaway or something that your favorite part of working on this project.
Yeah. So in our classes, we learn a lot of skills. We get to apply them theoretically, but it often lacks the hands-on component. So we're actually getting to build hands-on build spacecraft, build vehicles that are going to go to space, re-enter. It's an excellent way to develop our engineering skills and take it to the next level, to think a little bit more about how we're going to design these experiments to survive the reentry environment. And it's definitely helped me develop my skills as an engineer just by taking my knowledge outside of the classroom and applying it.
All right, Bruno, your turn. What's been your takeaway or your favorite part?
I think the coolest part is when you actually see it work. So we spend around at least 2 years for every mission, and then you have this moment where you're waiting to see if those 2 years they're always worth it, but if it's going to work or not. And then there's this one moment when you realize that it all worked, and then you see all your efforts get validated.
All right, so I am really interested in hearing what's next. Bruno, do you want to give us a little insight?
Yeah, so we have a series of orbital flights where we eject the capsules from the ISS, and we had 2 already. So the next one, called CRAPE 3, should be happening around 2026. That's what's next. We plan to fly a total of 10 capsules.
Mm-hmm.
And so what makes this, like, what are the differences between the last one and this one? Is there anything in particular that you're looking at in the test profile?
Yeah, so we always try to do some sort of improvement. So from the last one, there's now going to be 5 more capsules. So we flew 5 capsules for CRAPE 2. We're also going to be trying different shapes, possibly more materials, maybe some improvements on what data we're trying to get and stuff like that.
Mm-hmm. Yeah, and
All right.
I'll add to that. An important part of building that technology for the next ISS mission is we actually will send test payloads on smaller suborbital rockets, so sounding rockets, also through NASA. So we're hoping to get on a couple of those launches before 2026 to test some new technologies that we're going to send to the ISS as well.
So my last question for each of you is going to be maybe to think back to your younger self. What advice would you have for students who are interested in doing something like this, working on a big research project that's in aerospace? And why don't we start with Emma?
I guess my advice to my younger self is to make sure you're networking with your professors, make sure you're asking them questions, get involved in the things that they're involved in. And I think that makes really great connections for going forward, especially if you're interested in a specific area of study like aerospace. Trying to find your aerospace professors and getting involved with them is super helpful in furthering your career and your knowledge base.
Great advice. Asa, how about you?
Yeah, I would echo everything Emma said, and that can start as young as middle school and go all the way into college. Talk to your instructors and see what they have to offer, but look for opportunities on your own. For me, NASA experiences have offered me, I've been part of multiple NASA research projects and multiple NASA internships, so I've learned a lot through NASA experiences, and you can start that involvement as low, even in high school. There are NASA STEM experiences for students that are younger than the college level. So start looking for those early and be aware of what's out there.
Excellent. All right, Bruno, how about you? Advice for your younger self. What would you say?
Yeah, definitely just reach out. I think it's very possible to do all this fun stuff. There's a lot of opportunities out there, but they're not gonna come knocking on your door. So if you reach out, try to find stuff that you like to do, and the worst you're gonna get is a no. So just give it a go.
So don't be afraid of the no.
Yeah.
Just throw yourself out there. I love it. Make yourself known, get to know those professors, because the professors can really have a big influence on, getting asked or invited onto these teams and projects. So it sounds like wonderful advice. I don't have any more questions for you this afternoon, but we really appreciate the time that you've given us and some of the insight into what it's like to be a big part of a project such as, tell me how to say it again, crepes.
Preps.
Okay,
The
very
overall
good.
project is
And that
CREPS.
stands
And then
for?
Kentucky Reentry Universal Payload System.
All right, awesome. Thank you. We love our acronyms at NASA, so you're right in line and right in line with us. So thank you so much, and wish you luck on the next part of your research.
Thank you.
Thank you.
Next, we'll be chatting with students with the nationwide Eclipse ballooning project, which is sponsored by the National Science Foundation and NASA. Genevieve Picciano and Hugh Randall are a part of a larger team that became the first to measure what scientists have long predicted. Eclipses can generate ripples in Earth's atmosphere called atmospheric gravity waves. Hey, Genevieve and Hugh, thanks for joining us today. We're going to start off with some basics. So Genevieve and then Hugh, if you could each tell us a little bit about the project, what is the purpose of the project, and then what is your role specifically?
Sure. So I've been a part of the nationwide Eclipse ballooning project with the overall purpose of getting students involved in scientific ballooning for the 2023 and 2024 annular and total solar eclipses. Specifically, I helped with some coordination for the Plymouth State team and coordinating the super site in New Mexico from the 2023 annular eclipse.
And Hugh?
Yes. So I joined this project as not part of the ballooning side, but the more data analysis side. There were lots of different schools and pods that collected this type of data, either at the super site or at other points along Eclipse path, but it needed to be processed and filtered before we could actually get meaningful science out of it. So I was on that side, filtering it and making it so that we could get those signals.
So can you say a little bit more about what data you were collecting? What kind of data points?
Do you want me to?
Yes. Sure, yeah.
Oh, okay. So we were launching weather balloons with radio sounds on them, which collect the temperature, the relative humidity, the pressure, and then use GPS to calculate the wind speed and direction.
So almost like a little weather station going on the balloon.
Yeah.
Yeah, that's very cool. So then you're collecting all this data. Hugh, tell us, why is this research important?
So the big idea with this measuring the atmosphere during the eclipse is that it's such a specific event. There's really no other way that we can force such a big, large scale change in the atmosphere. When the eclipse happens, it essentially creates a column of air where all of the light is gone, it turns dark, and that creates big changes in the temperature, the pressure, and it's from the surface to the outer points of the atmosphere. So it's such a particular event that we can study. All we can do is make the most of it. That's why we worked so hard to launch so many radiosondes at so many different points in time.
So Genevieve, what has been your favorite part of this project, or what has been like your biggest takeaway?
Sure. So my favorite part of this project has been teaching the other students how to, launch these weather balloons that might not have had this experience before, which has also kind of been my biggest takeaway, is just seeing them enjoy something that I enjoy.
How about you?
I think that's a really great point. It seems like this entire process has been a big learning experience for so many people. I know specifically at Oswego, we also had a group launching weather balloons. So it was a big opportunity for them to learn this actual data measurement process, what it's like to do this sort of thing. There were myself and other students working on the analysis side, but there were also outreach opportunities where we went into the local schools and we talked to like the middle school and all the elementary schools about, what's an eclipse? How does that sort of thing, why is it important? And it was, great experience for everyone.
So it sounds like there are tons of benefits. So how did you find out about this? Like what would students need to do if they wanted to find out more about NASA student research?
I was very lucky. I was introduced to this through my professor, Dr. Shashi Kanber at SUNY Oswego. He was one of the people in charge of working with Dr. Gong at NASA, coordinating our launch site. And it just so happened that I had done a lot of work with Dr. Kanber, and Dr. Gong was looking for a student to do data analysis. So it was pretty much being in the right place at the right time, and having those good connections.
So how about for you, Genevieve?
I found out about this project when I was applying to grad schools about 2.5 years ago now. Dr. Eric Kelsey at Plymouth State was looking for a graduate assistant to help him on this project, which I was lucky enough to get.
Nice. So think back to like when you first got involved, when you first got started, or maybe when you were just thinking about, maybe I want to get involved in a research project. What advice would you have for a student interested, or even think back to your own personal experience? What advice would you have given yourself, like something that you would have liked to have known before getting involved? And why don't we start with you?
Sure. I think definitely when you are looking for these opportunities and looking to start on a project like this, you really just have to go in with an open mind, because you don't really know what it's going to entail, what sorts of things you'll learn along the way, and you just have to be prepared for everything. I know personally, my project, it started off, we had one goal, and throughout the months, it kind of shifted and changed and turned into something that we didn't really expect at the beginning, but it was really meaningful, and it was just a much better outcome that way. And it was a natural process, but it wasn't something we could have planned for. So you just have to be open and ready and say yes to everything.
That's great advice. I love that. I think that applies for life in general. Don't always, you have one plan, doesn't always end up where you thought, but maybe you end up somewhere better along the way. So Genevieve, how about you? Any advice?
I definitely think it's important to express your interests. And I know that can sound very like intimidating at first, but even just like reaching out to your professors saying like, hey, like you have this project going on, you might not have an opening right now, but like in the future, like, keep me in mind for any opportunities that you might have in that field.
So making sure you're kind of advocating your interest, knowing so that people know you are interested in that kind of thing should something come along.
Yeah.
Yeah. That's also great career advice too. I think that's something a lot of people can relate to. It's good to have people that when they're thinking about like, we do have an opening, and they go like, who would be good for that, right? If you haven't stated those interests or expectations, they'll never think of you. So that's wonderful advice. All right, so this question's for Hugh. Tell us what's coming next for this project.
Sure. So there's a lot that we've done already. I'm not too sure about missions wise, whether or not we'll be sending up more balloons or where and how that all works. But in terms of the science we're getting out of the data, there's still a lot more that we can do. We successfully detected the gravity waves that we were looking for during the 2023 eclipse, specifically at the super site. What made that so possible was the 4 groups all sending up weather balloons at 15-minute intervals rather than 1-hour intervals. That increase in time resolution really helped us isolate the signal from all the background noise and things like that. But that being said, there was a bunch of other data taken besides the super site, and there's still a lot that we can learn about how all of these things are propagating through the atmosphere across the eclipse path, the different lay of the land and how that affects everything. There's a lot to do.
So it sounds like you've got tons of data to sort through and it's just rich, ready for discovery.
Definitely.
Awesome. Well, I really want to thank you both for coming and sharing your experiences with us and telling us about NASA research. And we really hope to hear more from you in the future and continue to take those experiences and research skills and putting your interests out there, and that your career path ends you maybe back up at NASA.
Thank you very much.
Thank you.
Thank you. For those watching who are interested in learning more or joining this project, you can go to eclipse.montana.edu. Thank you for joining us today to learn more about the exciting research opportunities NASA has to offer. If you want to get involved with NASA research, you can explore these websites to find the right opportunity for you or your classroom.